Hey geometry friends, we're in chapter 1 section 6 and we'll be discussing two-dimensional figures today. So in our discussion of two-dimensional figures, we need to make sure these vocabulary terms are front and center in our mind and we understand what we're talking about. The first one we'll discuss today is a polygon. So a polygon, many-sided figure. A polygon is a many-sided figure where it's made up of several segments that connect in exactly 2 points, the endpoints, such that you might have a figure like this. So a polygon has a couple of characteristics that we need to be mindful of, and basically it's that each of the sides are going to intersect like this, and this would not be considered a polygon. This would not be considered a polygon. Something with like an extended side where the side isn't really, where the endpoint isn't connected to the other endpoints. Also, one thing that we want to avoid is the fact that we can't have any curved sides to a polygon. So as beautiful as this is, because of this curved piece here, it would not be considered a polygon. So that's a general idea of what a polygon is. Sometimes we refer to different parts of the polygon, and one part we need to keep in mind is the vertex of the polygon. The vertex of the polygon would be the corner points, the elbow points, the points where two segments join together. The plural of vertex of a polygon would be the vertices, those corner points, those elbow joints of the polygon. So sometimes we talk about different types of polygons. One type that we will discuss is the concave polygon. And when I think about concave, I think about cave. When you think about a cave, it's a break in in a rock formation or whatever have you that you can crawl into. And so a polygon that is concave will have a shape that is, for lack of a better term, dented in. Okay, so this part goes in, and so this would be a concave polygon. We generally aren't going to talk about a whole lot of these polygons. One way that they define it in the text is that if you were to draw a line containing all the segments of the polygon, and some of those lines cross in the interior of the polygon, you know you're dealing with a concave polygon. All right, so if you were to draw a polygon and extend the lines of all the sides and realize that some of those lines are going inside of that polygon, then you know you're dealing with a concave polygon. But I kind of think it just looks like it's been punched in or there's a cave there. And convex polygon would be this guy over here. This one that we drew in the beginning is a convex polygon. So convex polygon, all the sides are, for lack of a better term, out. Or if you want to continue with that definition we talked about, if I extend all the sides, if I draw the line that contains each of the segments that make up the sides or the edges of the polygon, right? Notice that none of these sides cross the interior of the polygon. So we've got polygon, vertex of a polygon, concave polygon, convex polygon, and then we talk about n-gons. So the names of our polygons, so I think you guys have probably seen this before. When you name a polygon, it's named for the sides. So you guys know this one to be a triangle, and we know this to be a quadrilateral. And right in the names of these guys, you can hear the number of sides, right? Triangle, quad meaning 4, penta meaning 5, and octagon, 8, and hexagon or septagon, hexagon meaning 6, and septagon, all of that stuff refers to the number of sides. Sometimes we'll be talking about really large figures with multiple sides, and we call that an n-gon. So an n-gon really just means a polygon with n sides. So an n-gon could refer to, I could honestly call a polygon a 3-gon. I could say, hey, this is a 3-gon, this is a 4-gon. Not typically 4-gon, get it? Okay. Not typically used, but you could do that. And a polygon with n sides, if we're talking about some generic polygon, I can say I have an n-sided polygon, which is an n-gon. All right, so an equilateral polygon and an equiangular polygon are really important. Equilateral, the word lateral refers to sides. So if I have an equilateral polygon, I'd be referring to a polygon with all equal sides, or whose sides are all equal to one another or congruent, right? And if I have an equiangular polygon, what I'd be referring to here would be a polygon with all equivalent angles. So with our equilateral polygon, we're dealing with the sides and they're all equal. And with our equiangular polygon, we're dealing with the angles and they're all equal. So what's a regular polygon? To me, I find this it's not really it's not an oxymoron, but to me it's an oxymoron in my mind. Like, it seems like it's two opposites. A regular polygon to me is quite irregular in that it has both of these categories. It has both of these qualities. It is both equiangular and at the same time equilateral. So I'm going to put both colors here to kind of indicate visually that it's both of these. So a regular polygon, let me write a definition here. A regular polygon with all sides congruent and all angles congruent. And congruent is probably the better name to use when we're talking about these guys, because I'm really talking about a size and not a measure. Just a little specific business there, but I hope that makes sense. We're talking about regular polygons. So for instance, let's go back to these definitions and just think a little bit. A polygon with all equal sides, well, that could be a rhombus here. I'm going to draw a rhombus where each of these sides are supposed to be equal, and that's a pretty cool equilateral quadrilateral, sorry for the big words. And here I'm going to draw an equiangular rectangle where each of these angles are 90 degrees, right? So this is equiangular, this is equilateral. When I bring it together, the love child of these two would end up being a square, right? A square, because we know a square has all equal sides and all equal angles. Sorry for the sound effects. They make me happy, but probably not other people. All right, so we've got this guy, which is a square, and this square is a regular polygon. And I think it's so irregular to get a perfect square that I'm like, why do they call it regular? But that's just my issue. It is a regular polygon. So a regular polygon has both of those qualities. Let's just go ahead and finish off with perimeter. Perimeter means the length around the sum of all sides, or the length around a polygon, the distance around a polygon. And when we talk about the circumference, we're talking about the distance around a circle. So that's circumference and perimeter, the distance around a polygon and the distance around a circle. And finally, when we talk about area, we're talking about the two-dimensional space covered by a figure, the two-dimensional space covered by a figure. Okay, with that in mind, I know these notes look wild. I hope they make sense as we discuss it. Of course, you know that all of these definitions can be found in your text. But with that in mind, let's go ahead and take a look at some examples. Okay, before we hit the examples, I just want to show you a little bit of a visual. Here are polygons. Here are not polygons. Notice this is enclosed. This has this weird cross in the middle where we form two shapes. These are actually two polygons here. This and this are examples that we talked about. Here we have curved sides. These are polygons, with this one being a concave and the other being convex. All right, here also I want you to observe just the number of sides. We know a triangle, quadrilateral, pentagon, hexagon, heptagon. Sometimes you might see septagon as another way of referring to a seven-sided figure. This one's my favorite because I can make a joke about it, something about septa. Okay, nobody cares. All right, and then we have octagon, nonagon, decagon, hendecagon, dodecagon. I expect you to be familiar with all of these words, and after we get past 12, we just start going n-gon, so 13-gon, 14-gon, instead of referring to the actual Latin name that was given to these different shapes. All right, so here in example 1, we're going to name and classify the polygon. So the first thing we're going to do is name the polygon by the number of sides, and then we're going to classify it as convex or concave, and then regular or irregular. And so as I look at this guy here, I notice that it has 1, 2, 3, 4, 5, 6 sides. Six-sided figure, if you remember from the brief look back there, is a hexagon, and we recognize that it has all equal sides, but it does not have all equal angles, as the figure indicates here. So it is not regular, it will be irregular. And I need to answer the other question, is it convex or concave? And you can see it's punched in here, so I'm going to say it's concave. All right, so those are the 3 bullet points about this guy. Let's take a look over here. So here we see we've got 1, 2, 3, 4, 5, 6, 7, 8, I believe. Let me count again. Yeah, we've got an 8-sided figure, which we know to be an octagon. And we have a figure that we can see does not have any punched in sides, therefore it's convex. And with all of the sides and angles equivalent, we know that it is a regular polygon. It is regular. Now, to get through some of the next examples, we need to have some things in mind that we need to remember. And our text is really nice about putting up these really neat charts. And here's a chart that's found in your text on what page is this on? It's on page 58, and you'll see that it gives us a triangle, tells us the perimeter where we're adding up all the sides, tells us the area is 1/2 base times height, and it does the same thing with the square. If you wanted to find a square's perimeter, this is what you do with the sides, and this is what you do with the sides to find the area. And this should be familiar. This is probably the one that most people forget to memorize or something. So the circumference of a circle is 2 pi r, or pi times d. The reason why that can be stated in either of those ways is because we know that 2 times r is the same as d. We recognize that two radiuses would equal a diameter. And we recognize also that pi is sometimes used to represent, or pi is sometimes equivalent or said to be equivalent to 3.14 as an approximation, but we know that this is an irrational number that continues on and on forever. So sometimes you'll use this, or sometimes we'll just keep pi right in our problem. So if you don't know this, you need to make sure you know it, especially for the next few problems. All right, now that we've got that together, let's go ahead and take a look at this example. Find the perimeter or circumference of each figure. So we remember to find the perimeter is the sum of all sides. So we'll do that here. This side has to be 2.1 because it is a rectangle, and we can assume that this side is 3.2. We'll add up all of the sides to get 10.6 centimeters as the perimeter. And you know, there's a formula that says you can do 2 times one side plus 2 times the other. We can do it, add out all the sides. That's totally fine. The circumference of a circle is given as 2 pi r, and so in this case r is 3, the radius is 3 inches, so we can say that that's equal to 2 pi times 3, or 6 pi if we're leaving it as in the pi form, or we could approximate pi to be 3.14 and get 18.84 inches as the circumference of the circle with a radius of 3.